All right, so finishing up groundwater conversation from the other day. Subsidence. So this is one word where you guys know what it means to subside. All right, and you may have even used that word in a sentence or two throughout life. In earth science, it refers very specifically to the compaction of the earth, the sediment, if you would, due to the removal of groundwater. So we know that stuff floats in water. Buoys is the word they use, right? It buoys up. Yep. And what?
I think the word is
buoyancy, yeah. And buoys up is similar spelling, different conjugation. But yeah, buoyancy is what we're talking about. It makes stuff float. Okay? So anywho, remember all that pore space we talked about? When it is full of water and not just air or gases, it is swelled up, for lack of a better word. Okay? And if that's its normal state, then that's what you get used to. That's what you accept as normal. When that water leaves, things can compact. Things can squish down. And I know all that to be true. I've seen all that to be true in geology. We talk about mud cracks, which are features that you see out in the world around you. You've seen them yourself. You probably just didn't pay any attention to it. After a mud was really, really wet and you had a nice sun-baking day the next day, the surface kind of can be all cracked and look kind of like scales or lizard skin or something like that. So I know all that to be true. Yet I still have a little difficulty believing this picture. So what is this picture trying to convey to us? Well, you see this little old man sitting there, and it looks exactly like my great-grandfather, especially right around 1975 or so. I didn't remember him that well because I was only 5 or 6 or so. But I remember him looking exactly like that, so I'm going to say this little Italian guy. It also looks like he's standing next to Great Plains. So, all right. So we're going to assume that this is, and it's also in San Joaquin Valley, which is California. So we're in San Joaquin Valley in a grapevine area in 1977, and this little old man is standing there for a reason, presumably. We look at the rest of the sign. We see 1955 on that telephone pole, and we see 1925 at the top of it. It is quite likely that that little old man has been there for 50 years and is one to know and or talk about this situation. In the context of subsidence, what they're asking us to believe is that the land has actually subsided that much. And that's what I have a little trouble believing, but why would they lie to us? All right. We do know, just from common knowledge, let's say those are grapes, that grapes use a heck of a lot of water. Okay. So any water that's brought down in there, and again, they use a lot of irrigation over there, so that's another argument. But nonetheless, any water that's there, if you're growing grapes, man, you're sucking it up like crazy. Okay. But still, that's a lot of compaction. A lot of compaction. Someone in the last class was saying, well, that because I was pushing this little conspiracy theory idea, and they're like, well, that telephone pole, I mean, why it wouldn't have been, he's arguing that the telephone pole wouldn't have been buried that deep. I totally agree. I'm sure if it sank that fast, that fast, the telephone poles would have fallen over. Also, going back to the fact that it's 1925, if they even had telegraph lines back then, I doubt it would have been telephone lines. I don't remember when they did their telephone thing, but there's a good chance those poles weren't even there then.
Western grapefields look very poor, right? And there has to be some amount of water, but if they're sucking up that much, then those plants wouldn't be growing that well.
Again, I'm guessing definitely irrigation now. In this part of the valley, they carry, I don't know how good your guys' geography is, mine's pretty bad, but they actually bring in a lot of water from the Colorado River, which is over by the Grand Canyon. They bring it in that far. But because the weather is so awesome over here, temperature-wise, for many, many years until we could afford to get like oranges from South America. You know, California and Florida and Texas, even if they didn't have, Florida has the rain, arguably, but some of those other areas, even if they didn't have the moisture, they certainly had the rest of the weather. So we would pipe water in order for them to grow vegetables and fruit for us all year long. So, you know, there is that. They'll certainly keep that stuff looking great. It's just like the people who have lawns in Arizona. And they're supposed to have, you know, grass doesn't grow in Arizona naturally. But we have it. So, you know, we're smart little monkeys. We make things work for us as much as we can. But yeah, so this is a lot to swallow, but that is the idea at any rate. Now, a lot of our use of subsidence, however, is definitely incorrect. You guys were babies, I suppose, when this happened. But you remember when New Orleans flooded, okay, after the hurricane? It was ways back, but it was in the news for a very long time. And basically because New Orleans is a giant bowl, they had some problems with their flood walls when the hurricane came through. And instead of preventing the water from coming in, it ended up trapping the water in a lot of cases. It was a hell of a hurricane, though. Okay, there's some things you just can't plan for. For about a year and a half, if not longer, after that, New Orleans, Louisiana in general, was in the news, and because everyone's trying to throw blame everywhere except where it should have been, the big argument was, well, Louisiana, New Orleans is sinking, subsidence, and that's not what's going on there. Yes, it's being erased, but it is not because it's sinking. It's not flooding. What river's coming right down there? Anybody? Comes all the way through the middle of the U.S. and down there and into the Gulf of Mexico. Biggest river we got, more or less. Yeah, the Mississippi, okay? And that Mississippi is heavily used for trade. We run ships up there. Even nowadays, it's hard to imagine with all these Amazon trucks and semis everywhere that we still use trains and boats, but we do. A lot. And so that is very heavily used for these giant ships that come up practically all the way to Chicago. If not all the way to Chicago, again, my geography is horrible. But Mississippi goes way north, okay? And we bring stuff on there. Because of that, we need to keep that river clear and free, which means they are constantly, the Army Corps of Engineers, government, constantly removing sediment from the stream. Now, we haven't had a whole lot of background on this in here, but you're probably aware that streams carry sediment. They leave gravel deposits, sandbars, so on and so forth. You've stood on them, you've seen them. You may have even heard of a delta at the end of the stream where the sand, kind of plays out there. All right, streams carry sediment. You also know that waves are really good erasers, okay? Constant battering at the shoreline. You've heard about these houses. Generally, they show you in California, all these people living on cliffs, okay? And basically the rock underneath them is entirely eaten out, and their house is either on stilts or dang near. Okay, the waves are very effective at eating away at the land. That's how they make sand. So for however thousands, millions of years, Mississippi's been coming down there into the Gulf, and the waves in the Gulf have been wearing away. It is kept more or less at an equilibrium, a stasis. Arguably, it was bringing more sand down than the waves were erasing, and maybe Louisiana even grew a little bit. But once we stopped letting that sand come down, we basically put big strainers up, and we pull that sand out. Well, I guess that equilibrium shifted, and the waves just basically started erasing Louisiana way faster than it was being built. That's why Louisiana is sinking, in quotes. It's not sinking, it's just being erased. It's like if Manhattan was slowly, or Cape Cod, or whatever beach of your choice, okay, was in Massachusetts. Okay, it's a big old spit of land that sticks out into the ocean like a fern frond. So, anywho, it's just like if that was being erased, day by day by day. So that's what's going on there, but we use the term subsidence. Again, probably the media grabbed onto it or something happened there. So subsidence is a thing. This is a very extreme example. Next is karst. Karst, and they first came up with this in Germany, or at least they first wrote about it over in Germany, so you have this sort of German-sounding name.
Karst.
All right.
That does sound a little German.
Yeah. Karst refers to the interaction of limestone and water. Water dissolves all things given enough time, but limestone, very much so, very rapidly, very easily, whatever word you want to say. All right. The earth is old, she's cracked, and water goes through those cracks. We've been talking about that, and you probably knew that anyhow. But in limestone, what happens is it gets in those cracks and it dissolves those cracks, makes them even bigger. Then the next time, more water could get in, they get even bigger, so on and so forth. And eventually you move from that first diagram to the second diagram. You could even still keep the water in it for this second diagram for a minute. And you end up with these big holes underground full of water. And that's not a problem, going back to our conversation about water buoying things up. Okay? Not a problem because it's essentially full. You may as well still have rock there. However, we come along and drain out that water. Again, whether we're throwing up a new subdivision or we start a bottled watering plant, water bottling, whatever, you know what I mean. Water bottling plant. We talked about Nirvana the other day. Whatever the reason, and your water table drops significantly and more or less permanently. You end up with these big open cavities. Now, everybody loves going to house caverns. I assume you've all been there. It's essentially what we're talking about. They build that visitor center any bigger, God forbid. Maybe someday, and hopefully they didn't even build it over the cavern. I don't know. I think it is right over the cavern, though. It could, in theory, collapse. Okay?
In theory.
We're going to go, and this is the dark side. Sure, karst has a lot of cool stuff. Everybody loves stalactites, stalagmites, but there is a dark side to karst. So we've got these dripstone formations. Sometimes they call them dripstones. Sometimes they call them flowstone. It depends what they build. But the general idea is that these are all calcite formations from water flowing. Why are they calcite? Because limestone is made of calcite, and that's coming out of the water. If you're finding it hard to picture that, again, think back to your house or maybe somebody's house you visited where they might have iron deposits, iron stains in their sink or in their toilet. It's the same idea. Over time, some of the stuff that's dissolved in the water can come out. Now, as deep and as dark and as humid as these caves are, it's hard to imagine this water evaporating. But, when you think about it, you have water with stuff dissolved in it. Only water evaporates. Calcite doesn't evaporate. Salt doesn't evaporate. So we get these deposits left behind. So these dripstone formations, the stalactite and the stalagmites, you get one forming from the ceiling where it's dripping off, and you get one directly below it where it's landing. And again, over time they build up, and sometimes they could even join and form something called a column. Okay, we don't have a column on here. I think it's in the next picture. Now, okay, there you go. Yeah. House caverns doesn't really do stalactites and stalagmites. They've got these silly little things, I think they call them straws from the ceiling. They much more do flowstone, which I think is actually kind of cooler looking. It's like a whole bunch of really fancy wedding cakes in there. But the flowstone is the same idea, okay? Instead of coming out of the ceiling directly, they're getting much more flow through the rock layers from the side, I guess is how you would explain that. Now, if you're like me, you struggled to keep stalactite and stalagmite separated. My teachers weren't really great. They told me mites, mites like bugs. So that helps. And I guess they were trying to say bugs crawl on the ground, but I've seen enough bugs in my life to know that they're also on the ceiling. So that didn't really help me. What did you guys learn to keep these separate? I had a couple thoughts in my geology class last class. If you're on a ceiling, you got to hang tight. Yeah, that's a good one. Anybody else? I've heard some pretty strange things over the years. I finally came up with, when I was trying to give something for you guys to remember, stalactite, C ceiling, stalagmite, G ground. Okay? And if I had learned that in third grade, well, maybe I would have got a doctorate instead of just a master's. No, I don't know. But at any rate, so stalactite is ones that hang from the ceiling, the dripstones from the ceiling, and stalagmites are the dripstones that form on the ground beneath them. And if you already know something that works for you, God bless, and keep doing that. But if you didn't have a way to get these two multiple choice questions right on the next test, I recommend C ceiling, G ground. All right, so karst topography. Topography is the lay of the land, what things look like. You look out the window here, you're looking at topography. So you see a lot of stuff, okay? Little holes here and there. Sometimes streams disappear into them. Sometimes there's some cave entrances. Not the best diagram, but it's what I had. All right. And this is where we like to start talking about caves because everybody thinks caves are cool. And then around here you've got a little bit of lore or legend, if you would. Back in the days of the Prohibition, when they banned alcohol for a while. Okay. Yeah. And Utica Club over here was serving alcohol a minute and a half after Prohibition was repealed. So some places never stopped brewing it, apparently. But overall, generally speaking, it was banned. So they used to talk about, I grew up by Lake Erie, you guys Lake Ontario, and they never banned it in Canada. So they had these rum runners and so on and so forth, the gin runners. All right, and they would run stuff over from Canada. They'd hide it in the caves on our side, and we'd go and pick it up. Okay, similar stories going back, a couple centuries when you're down with pirates and whatnot. Okay, hiding stuff in the caves. And pirates take it even a step further because you have tides when you're in the ocean, right? Great Lakes don't really, tide level doesn't change much, but there's these little, because it's limestone. Ohio's limestone, Michigan's limestone, New York's limestone. It's all limestone. But you go down south and you talk about the ocean, you're still looking at limestone, but you've got the effects of tide. So then come the stories about this secret hiding spot that's only accessible. We'll use one of our vocabulary words during spring tide, right? At one of your lowest tides. Okay. And actually, that's neap tide. Only accessible during your lowest tide. All right. So 2 times a year, maybe you could get into this special place. You picture 2 guys on a rowboat going in to pull out the booty and all that stuff. I love Goonies. Don't get me wrong, but never a big enough difference to get an entire pirate ship in or out. Huh? Goonies. It's a movie you need to watch. So never to that extent, but certainly it's within the realm of reason to think that there were places that you could only get during low tide and so on and so forth. Question?
Why is there like giant pit
The sunken areas there?
Yeah.
We're going to show you in a minute. Good question, though. So as I said, there is a dark side to karst, and they're called sinkholes. Sometimes you get warning when something like this is going to happen. Sometimes you don't. And remember what I said, everything's fine and dandy as long as the water is in there still supporting that empty space that was dissolved by the water. But if it's removed over time and as we keep developing and building stuff on top of it, sometimes it just says enough is enough. Now, thank goodness this hasn't been in the news too recently, but one of the last times it was in the news, it was down in Florida. There's a half of a subdivision just fell into the earth. It was during the middle of the day, so thankfully a lot of people weren't home. But there were a handful of folks who worked the night shift or whatever. One guy slept right through it and is just still buried there, I guess. Because you would hear the cracking and crumbling, and if you were awake, obviously you would hopefully try to run away. But it just took, like I said, half a neighborhood inside. It's hard to get scale here, but I usually throw people over to the road here for reference. So it looks like you've got 2 lanes going one way, 2 lanes going the other. I go back and forth on whether there's a turning lane in the middle there. Short of this factory or plaza, whatever it was, there's not a whole lot of reason to have a turning lane there. So I think it's just 4 lanes wide. That gives you some idea of scale. Also at the bottom of the picture there, sort of in the center, is either a trailer or more than likely an air conditioning unit from the roof of one of these buildings there. It's tough to tell. Yeah, it does. It really does. And again, that's only on nice projectors like this one. You know, that some of this stuff is coming into focus for me. We talk about how technology helps science. You know, when I showed this as a fuzzy old overhead back in the day, we didn't get to see detail like that. But I honestly don't remember seeing that camper there in the past. But regardless of how explicit our understanding of the scale is here, that's pretty freaking huge. I think no one could argue that. And you get little to no warning. Sometimes it'll start to slump a little bit, sink a little bit, for lack of a better word. And scientists will warn you, caution you, maybe even say this building is condemned. But in this case, it took a lot of space with it. So sinkholes do happen, huh?
Was this update of debris, Henry? Because it looks like there would have been way more stuff in that.
Yeah, it's tough to say. This is an old slide, and it's back when really textbooks, they'd still give a photo credit, but they wouldn't necessarily give you that whole little paragraph next to it to explain stuff. They would just talk about sinkholes and then say, here's a picture of a sinkhole. Yeah. So we don't really know a whole lot. Again, because the trailer's there, we see some building refuse there. I'd hazard to say that they haven't done a whole lot of work here. But, along the same lines, again, I don't know if people were killed or injured during this collapse or if they had actually managed to vacate the building. It's just a really extreme example of a sinkhole, so that's why we're showing it to you. Now, again, misuse of the term. It hasn't happened here in a while. It did when I first came to town. But every so often you'll hear on the news, today in downtown Syracuse, a sinkhole opened up and FedEx truck falls into the earth. All right. That's not because of limestone. It's not because of karst. Think about what you have, especially in these older towns. You've got the water pipes, the sewer pipes that are there. They've been running for years. They're old. They're leaky. Okay. Flowing water transports sediment. And what happens a lot of times is that the area underneath the road, the blacktop, just gets hollowed out. And, some poor sap pulls up his truck onto the curb to make a delivery or run in and get a sandwich, comes back out, finds a truck in the ground. It happens, again, with some frequency. But that's because of the old pipes and the fact that water erodes. Okay. Strictly speaking, not a sinkhole. Yes, a hole opened and something sank, but short of that, no. So, anywho. All right, so that's all I've got for you guys with regards to groundwater. Forever with groundwater. I'm going to take a gander through and maybe write a new lecture or two over the weekend. We'll see where this heads us. We've got streams to talk about. We can talk about glaciers in the Ice Age. That's usually fairly interesting to you guys because, again, you've grown up in an area that was affected by the glaciers, is affected. And Ice Ages do kind of play into our conversations about the environment. So we'll quite possibly squeeze that into the conversation. And things are playing out. Okay, remember we've got our last lecture on April 30th. Our last test on April 30th. So the last lecture is actually the week before that, which means I think we've got 4 left. So I'm running out of time. So it's all right that we're running out of topics, Questions about groundwater?
No questions.
Well, other people may have some. Not the case, but you never know.